Welcome to our West Virginia College and Career panel on manufacturing. And this is our second session. And I am Travis Williams with the Teacher Enrichment Program with the Center for Excellence in Education, which was founded in 1983 by Joanne DeGennaro and Admiral Rickover, who is the father of the nuclear navy and civilian uses of nuclear power, with a mission to nurture high school and university scholars to careers of excellence and leadership in STEM. We do have several programs in our organization for teachers and students, which is our Research Science Institute, our USA Bio-Olympiad, our Teacher Enrichment Program, and newly to our programs is our STEM Lyceum. Today we have two dynamic and exciting speakers. We have Matt Thrasher, who is a Senior Product Manager and Trucking Planner with Waymo, and we have Michael Thompson, Senior Welding Coordinator with Equitrans Midstream Corporation. And with that being said, we're going to go ahead and start with our first presenter, which is Matt Thrasher.
Thanks, Travis. My name is Matt Thrasher, and today I'll be talking about my STEM journey and some reflections on career and outlook for STEM education. I grew up in Oklahoma, and so just starting out as a student, I think a lot of my STEM inspirations came from just the nature around. Oklahoma gets lots of thunderstorms, and thought that was inspiring. Similar patterns, seen around nature, such as snowflakes, as well as reading science fiction and being interested in geology, as well as like working on my first car. Brings back some echoes you'll see in my career later. So yeah, starting with my fantastic experience at the Research Science Institute, which CEE runs. I did performed research at the Harvard High Energy Physics Lab, looking at muons. We were building an experiment for Fermilab, and that was really, fantastic for first experience. And I met some of my closest friends I still have today during those 6 weeks, and had not thought about applying to Harvard before then, which I did end up applying and attending. So after my PhD studies in physics, my first job at a school was looking at the interaction between sound waves and bubbles with applications for the Navy. And then that led later to a career in industrial and medical sensing. So this is large platforms with many thousands of sensors, trying to understand not only what's happening on the platforms themselves, but then in the environment as well, both in the heavy industry, oil and gas, and medical applications. This has some commonalities then with my career today in autonomous vehicles. So it's a moving platform with many sensors on board, trying to understand not only the environment around it, but the decisions that the vehicle has to make. So today I'm a product manager for connected and autonomous trucks. As you can see there, an example on the left, the blue truck has special computing and sensors on board that allow it to sense the environment, the objects around it, as well as making decisions about how it should drive within that traffic. And so my focus is on specifically the planning system, which means how the truck decides to drive. You can think of this as an interactive activity where what the truck decides to do affects the traffic, and of course vice versa. And so a lot of machine learning and artificial intelligence is involved, as well as collecting lots of real world data. And so from a manufacturing point of view, a lot of the work is from the very earliest stages, the basic research, leading to the applications themselves, and then going more in towards the advanced engineering, and eventually making that into production at large scale. And so the journey does not stop at production. You can think about then the lifetime of the service requiring maintenance and upkeep of not only the hardware, but also the software, such as the machine learning models requiring upkeep. And then finally, of course, end of life for the product itself, thinking about sustainability. So just a quick introduction into what product management is. So while developing a product, really we think along three major dimensions, which is the technical feasibility, the product desirability, and then the financial viability. So this means that, technically, we have the technology and knowledge and sophistication to build the system so that it works. We also have to consider what we build will be desirable for our customers in the end, and there will be a market for it that of sufficient size to sustain a viable business. And so part of the work product managers do is just making sure that we solve the right problems to the right level of depth and detail at the right time. So specifically the STEM skills that students would need to gain or learn to be successful in this type of job is really a mix. And so I've listed here the top 7. So of course, critical thinking is integral, as well as some general and special scientific and engineering domain expertise. I think typically how folks talk about this is T-shaped. You could also have W-shaped or pie-shaped or cone-shaped here, as RoseRock.io has put together. But the horizontal dimension is essentially general or broad knowledge, and then the vertical dimension is areas of detailed expertise. And so, of course, no one can know all the areas of expertise to infinite depth. And so there has to be some optimization across how broadly the knowledge is and how many areas of expertise you have. So for a product manager, it's good to be an expert in 1 or 2 areas as well as having broad knowledge. The other skills, I won't read through the list here exhaustively, but essentially it does mirror much of scientific activity. So being able to have conversations and discussions with your colleagues, ask questions and listen to the answers carefully, perform active listening, and really exchange technical ideas that allow the product to be built properly. It's an active field of research, and so there's always more knowledge each day than any one person can learn. And so you have to be focused on choosing which STEM skills and which fields to keep up on. And a lot of the decisions have to be data driven. And so then the experimentalist mindset comes in of designing the right experiment to collect the right information, to be able to make the right decision, or perform an analysis to get a result that's going to drive the product forward. And then part of that analysis involves computer programming. And because it involves so many different pieces, I find very detailed note-taking allows me to crystallize and document the insights that I can then present out and articulate in structured argumentation in presentations or recommendations to others. And so as far as what teachers could do to support students who are interested in building products in the robotics and autonomy space, I've listed here a few of the things that I've found especially helpful in my own paths, supported by a great host of many fantastic teachers. So even starting in middle school and high school, attending summer camps. And I think the encouraging point for one overarching theme here is like the summer camps themselves were free to the families, often supported by local universities or like the National Science Foundation. And then also moving on through educational programs all the way up through a PhD program. I think some students might not know that those programs themselves are often paid positions as opposed to having the students having to take out additional loans for the PhD programs because they're teaching as well as doing research. Also, just reaching out to university laboratories, manufacturers of equipment and supplies, talking about what project you're doing and what supplies you would need for the project. I found that most companies are more than willing to help for educational causes. So with that, I'm looking forward to having a good Q&A session.
Again, thank you so much again for that, Matt. And I did mean to mention that you are an RSI alum of the Center for Excellence in Education. So glad that you could, again, participate and be with us today. And we're going to get ready for our next speaker. which is Michael Thompson.
So my name is Michael Thompson. I work for Equitrans Midstream, and my subject that I'm going to be discussing today is welding and welding inspecting on a natural gas pipeline. Okay, so here's a bio. Identifies, the company I work for. So as a welding coordinator, my main job is to ensure that the gas company has certified welders welding on our pipelines. So my primary function is testing of welders, both in-house and contract personnel. And I also review welding procedures and help with the welding engineer to perform procedure qualification tests. Some of the things I've done in my life, I spent 4 years in the Navy, none of which was welding related, but it did give me an understanding on mechanical equipment. Then the next phase of my career, I spent 13 years in the Plumbers and Pipe Fitters Union out of Morgantown. There I gained a lot of knowledge on welding and pipe fitting. And at this time, I am currently a master plumber with the state of West Virginia. And when I left there in 2007, I did join with EQT. It's a natural gas company. We have separated off of them. So now our company's name is Equitrans Midstream. And I've been with them for a little over 14 years. All right, next slide, please. Okay, so Equitrans Midstream is primarily focused with transmission pipelines and gathering pipelines in Southwest Pennsylvania, Northern West Virginia, and into Ohio. We have approximately 950 miles of regulated pipeline. When I say regulated, it's regulated by the DOT, by the government. They come in and ensure that we're building our pipelines safely, to carry this hazardous product around the communities in which we live in. Since we have 580,000 plus compression horsepower, so a lot of our facilities, our pipelines have to pump the gas along, help push it, down the pipeline. So every maybe 5-10 miles, we have to have a compressor unit to help push that gas along. And right now we're pushing about 8.3 billion cubic feet a day through our pipelines. We've instituted building water pipelines in several areas, and this is to help with the fracking of the wells. Some of our customers, our well producers, need the water, and it seems to be much safer to pump that water in a pipeline than to transport it, through a truck through all the communities. So that's another offshoot that we're doing, is trying to get less truck traffic off the road to those well pads. We're using pipelines to do that. Okay, to kind of help the teachers, the educators understand the necessity of, education that a welder may need. Here on the left-hand side, just a basic overview. So whenever I first started welding, I needed to know applied math or some algebra, the basic science, just an understanding of AC and DC because of the welder hookup, a good blueprint reading knowledge, understanding the drawings, so that we ensured that the pipes go where they're supposed to go. Reading comprehension. The students need to be able to understand how to read the welding procedures. To be a good welder, ensuring that they're following proper preheat requirements, ensuring that the procedure meets the materials requirements, and then ensuring that they had correct electrodes and the bolts and amps for those procedures. Good understanding of shop mechanics is also great. They're going to have to learn how to use the tools of the trade, most generally hand tools, electric grinders, and then torches. But yeah, just a good understanding of shop mechanics, also the safety that goes along with it. For the advanced welders, and if you ever want to become a welding inspector, you will want to gain some more knowledge. So a lot of the certifications, or also degrees that you may want to go into, like welding engineering, mechanical engineering. You're going to want to know some more advanced mathematics, getting into your algebra, trigonometry, possibly even the calculus mathematics, chemistry, metallurgy, physics. You have to understand the processes and the material that you're going to be dealing with. And then the metallurgy, ensuring that what stresses that you're putting into your metals, can those metals sustain those stresses, or it'll possibly cause cracks or other discontinuities during the welding process. Places to learn to weld. Here I've got a picture of a gentleman at one of our local community colleges. This community college has what you see as a virtual reality welding machine. So the gentleman has a hood on, and it has a screen inside the hood that's connected to the computer. So as he moves this electrode across this piece of plastic here, he's literally seeing and hearing as if he's performing a weld. And you can see on the screen in the background, the bright little white light. That's a view that he is also seeing in his lens, replicating a weld as he's performing it. So this is a very safe situation where he's at. He's not having to worry about sparks and slag coming off of it. So you can practice welding here without having to waste electrodes and pieces of metal. And you just practice over and over and over, and to kind of help your technique get better. Some of the places where you may learn how to weld. I first started learning how to weld in high school in an FFA class. Other places, on the job training. Some companies, they'll see that their workers may have an affinity towards welding, so they'll bring them in under tutelage with another welder, and then they'll train them up. I also went to a union apprenticeship, so I was in an apprenticeship for 5 years, and during that 5-year process, I had a whole year of welding, so that's where I learned how to weld. VOTEC schools. So some of our high schools in West Virginia have a VOTEC associated with it. So that's where the students go during high school, but that can continue over, and after you graduate, you can continue with the VOTEC to learn the welding processes and whatever's available to that school. There are professional schools to learn how to weld. 2 of them I've listed here, but there's probably more out there. So Lincoln and Hobart. Both of these are found in Ohio. Lincoln is found up near Cleveland. And I've visited that facility. It's a really nice facility. If you have the chance, it's great to go in there and check it out. Next slide, please. Okay, so during the manufacturing of our pipelines, some can be maybe a mile long, others can be hundreds of miles long. We may utilize many types of processes, welding techniques to do that in. Most of our pipes are built using SMAW or stick welding. So when we qualify our welders, that's the process that they will be using. But some of the larger pipelines may use some of these other types of processes. So MIG, TIG, flux core, submerged metal arc. Submerged metal arc will primarily be at like a fab shop. It's a big machine. The pipe will have to be on some type of a rolling machine, and it's almost automatic. The welder just kind of pushes a button, makes some slight adjustments, and just watches the puddle go in. But these are the primary processes that we will use when manufacturing and building a gas pipeline. So while the weld is being performed, the welder will have to make sure that every pass that they put in has good workmanship. So they'll have to inspect those passes. So they'll put these in like layers, and as they go in, they'll have to clean them off. And things that they're looking for are possible burn throughs, cracks in the welds, inadequate penetration, and porosity. There are a few other things, but these are primary ones. Some of these you can see on the outside circumference of the weld, but some of these can only be seen from the inside. So if they're welding on like a flange or something onto the end of a pipe, they can just look on the inside of the pipe. They should be able to see the root pass to check for some discontinuities or irregularities in the weld. So welding inspecting is very critical to the welding process. We need to make sure that the parameters are being taken care of. The welder is following the procedures. All the parts of the pipe are where they need to be. So here we're identifying when does a inspection required during the welding. So before the welding, we just obviously need to check to make sure the welder is still certified, that their card is current and valid, and that they're qualified for the procedures that they're going to be welding to. They need to check that material to make sure it meets the requirements of the job. And then they also need to check for safety. Does everyone have their proper PPE? Is their equipment in good working order? That order. Then during the welding process, our inspectors will come in and do an inspection during the weld passes. They need to check the parameters, the volts, amps, travel speed, make sure that they meet the requirements in the procedure. If they don't meet those requirements, then they need to stop the welder and determine, is it something that the welder is doing, or is it something that might be wrong with their equipment? So that's why we maintain those parameter checks. After the welding is done, we're going to do a final non-destructive testing. We primarily do 100% when we can. That's above and beyond what the regulators call for, but this is something that we feel is necessary for the safety of our pipeline. That non-destructive test includes, but is not limited to, visual inspection. So the welding inspectors will visually inspect those welds to ensure that they meet the workmanship requirements and the procedure requirements. But then we'll probably do like an X-ray of the weld, or maybe a UT, ultrasonic testing of it. Some welds require liquid penetrant or mag particle to test for cracks or other irregularities. And then once that's all completed, we'll try to make sure that we document as necessary, and then we store that paperwork as asset records.
I do have a few questions that I would like to ask you guys. And so this is to both of you. And Matt, we can start with you first. So what do you like about your career?
Yeah, it's a fantastic question. I think, working every day with people who are very passionate, involved, and smart, creative, it's a true pleasure. I think for me also, getting to work on sort of the leading edge technology is a lot of fun. It's an extremely complicated field, so there's always something to learn. Never gets old. I think it's also like more mission driven. A lot of folks in this field really want to help improve traffic, help improve transportation, help make everyone's lives safer, and spend more quality time with their family. And so I think the mission as well is very important.
Thank you for that. And Michael, same question. So what do you like most about your career?
Starting out in the welding profession was primarily with construction. I would help build schools. I would help build hospitals, other commercial companies. I enjoyed that. I was able to show my children as we drive by, hey, I helped build that place, I helped build that place. And it gave me a sense of pride, you know, seeing these facilities up and running and working the way they were. And then I made my way into the natural gas industry, and I became a trainer in the gas industry. And with being a trainer, I try to instill pride, letting these workers know that, you know, we need to make sure that we're doing this as safe as we can. You know, we're moving natural gas through our pipelines, and it can affect somebody if something, you know, was to go wrong. So just ensuring that, you know, we're doing this in a quality way, in a safe way. And then as I became a welding inspector, you know, I try to make sure that the people that we put out there are performing at the best that they can, you know, that they're knowledgeable about the industry and what they're supposed to be doing. And it just gives me, you know, a lot of pride in doing that.
All right. I appreciate both of your answers. And I know that can be you know, on the surface, a very easy question, but it can be kind of tough to articulate it. But I appreciate kind of how you guys talked about it, because part of what we want to do is, one, connect with teachers, for teachers to connect with their students on how we can connect the dots for students, so to speak. So, you know, that buildings aren't just up, you know, they're not just like in a Sims environment where they're just there. Someone had to have the technical skills to build those things and to design those things. And so it's you know, the same with you with AI. You know, we want to connect those dots so that students understand that these are fields that they can become interested in and work in and have a part in. Michael, I did want to ask, so do you guys offer like high school demos for welding? Because I know the photo that you had, I'm not sure if that was at a school or just at a college or university, but do you offer demos at high schools?
I don't. That was at a community college that I help out, that I assist, you know, for knowledge base on that part of it. I work with another online group where I give discussions similar to this to high school students. I've all the way from, like, I think elementary, 8th grade, up into the high school. So as an industry person, I discuss what we do within our industry.
And so Matt, let's see. So I have a question. It says, you mentioned internships. Do you have any recommendations in West Virginia on, you know, good places for students to intern, to become, you know, product managers in robotics and AI?
So for me, I think internships can start as early as high school. I think there's no need to wait till after high school for internships. So I think the benefit of having internships early is to get that exposure, right? It's a bit of a test. Do you like it? Do you like the field? Do you like the work? Is there sort of a natural affinity as well as like a challenge for the student to learn in the future? And so as far as specific places, I think that's probably something I have to look into it and get back to you, Travis.
Okay.
But I think in general, the earlier the better.
Yeah. Okay. And back to you, Michael. So, and I kind of had a question on this. So and I don't know if you know the answer to this, what are some of the metals that are used in welding?
So with our pipelines, it's a low carbon steel pipeline, but there is also stainless steels that can be welded on. A lot of the processes that we use a cellulosic covered rod, 60-10, 70-10, 80-10 type rod to weld with. But we also deal with low hydrogen electrodes. There's a large issue with hydrogen induced cracking in some of the pipelines. So we need to try to limit the hydrogen that can get into the welds. So that's why we might use a low hydrogen type rod. In my profession, as a plumber / welder, I've done soldering of copper, brazing materials, and also the welding. So I've dealt with coppers, brass, stainless steels, and carbon steel type products. I've not gotten into the titaniums or the other things like that, but primarily the carbon steel pipelines.
Okay. So again, I want to thank our amazing speakers, our RSI alum, Matt Thrasher and Michael Thompson, for your time and your you sharing with us today. And I thank any teachers that are with us today and that are watching this video with us. Again, thank you for joining us. Our links again are in the chat if you would like to get in touch with us. And until next time, you guys have a great day.